Com Software's webinar series on the Insitu Geo software. I appreciate everyone that was able to join and attend our previous webinar training on the cone penetration test. We really appreciate you and thank you for joining. And I also appreciate those of us present here today. I really appreciate you. So the software, the Insitu Geo software was developed by Com Software's company. So in this webinar, I'll be sharing my screen with you. The Insitu Geo software was developed by Com Software's company, and its first release date was 2017. The software is a combination of 8 Institute test programs, Insitu Geotechnical Engineering test programs, which are the CPT. Okay, we have the CPT. We have the CPT. It comes with an assisted mode, the electrical resistivity test, the flat dilatometer test, the pile load test, the plate load test, the pressurometer test, the standard penetration test, and the SPT also comes with an assisted mode for foundation designs, for easier foundation designs, and also the vein shear test. So what the software does, basically what the software does is to analyze test data gotten from the site, and you input your data into the software and you get outputs and foundation designs. And there are several benefits that you get using the Insitu Geo software. Like, you don't get to pay maintenance fee unlike other softwares. It's a one-off buy. It's a one-off buy. And as a licensed user, you get free updates. You get free updates. And it is the most affordable for the current features. For the current features the software has in the industry. And you can download a 1-month free trial of the software. You can download a 1-month free trial of the software with all its features unlocked. So today we'll be focusing on the pile load test, how to analyze data with the Insitu Geo software for the pile load test. And this webinar will last for 30 minutes, and you'll be required to rejoin using the same link you used to join for the question and answer session. So there won't be any break. So after 1 minute, after I end the meeting here, so after 1 minute, you can rejoin for the question and answer session. So without wasting much of your time, let me go straight to the PowerPoint presentation before going into the software itself. So yeah, the pile load test. Yeah, the pile load test is the most positive method of getting the pile capacity, and it's an important part of pile design, pile foundation design, sorry. And the results from this test are used to evaluate the ultimate load capacity of pile, and also the load to settlement behavior, and to verify your design assumptions. And you can also confirm it's also used to confirm the applicability of the pile performance, or to examine the structural integrity of a pile. So this test can be done on either a single pile or a group of pile, that's a pile group, be it cast or a driven pile. So this test is expensive and it is time consuming. So those are some disadvantages of this test. And the test can be carried out either on a working pile or on a test pile. A working pile, that is the pile that is being tested on, is going to carry load from the superstructure, and the maximum load that such working pile can carry should not exceed that's 1.5 times the design load. And for a test pile, the test pile does not carry load from the structure. So a maximum load of, say, 2.5 multiplied by the design load or the imposed load can give you, so as to give a total settlement not less than 1/10 of the pile diameter. So the test pile doesn't carry load from the superstructure. And here the pile load tests are conducted for determination of the vertical load bearing capacity, the uplift load capacity, and the lateral load capacity. So this is a diagram of a lateral load test, and this is an uplift load test, or a pole test. This is a pole test. Okay, and moving on, there are several methods of pile testing. We have the compression pile test. This is used to determine the load carrying capacity of a pile, and the uplift test, like we saw in the previous slide. In this slide, the uplift load test, the lateral pile load test to determine the lateral capacity of the pile, and also the integrity test. These are the method of pile testing. And for the compression pile load test, there are several methods. We have the slow maintained load method. We have the cyclic loading method. We have the load in excess of standard test load. We have the constant time interval loading. We have the CRP, which is the constant rate of penetration method. The quick load test, the constant settlement increment loading method. And here we see some advantages and disadvantages of some of this test method. For the static maintained load, we have the reaction pile system and the Kent-Sledge system. And also we have the bidirectional load cells. So some of the advantages of the reaction and Kent-Sledge reaction system is that it suits all soil condition and all pile types, and the piles can be instrumented. Tension and lateral testing is also possible. But the setback of the reaction and the Kent-Sledge system is that you need to have a Kent-Sledge frame. They are required, and the Kent-Sledge tests are relatively expensive. And setting up and dismantling the test equipment involve working at heights, operations of working at height, and it takes a lot of time. And for the bidirectional load cell, the advantages of this is that it is very high test loads are achievable with this test. No reaction system is required, but the setbacks are that it relies on sophisticated pile instrumentation and analysis, and it suits only for board piles, and it is relatively expensive. Okay, that is for the static maintained load. So I'm going to be showing you some pictures of some of these methods. That will be in the next slide. And for the static constant rate of penetration, the reaction system is the same as that of the static maintained load. And the advantages is that it suits all pile types, and the manual and automated systems are available. But the setbacks are, it requires a frame, just like the static maintained load, and the Kent-Sledge tests are relatively expensive, and is limited to cohesive soil. It's limited to cohesive soil and may over predict the ultimate load. And also, lastly, we have the rapid load test. And the reaction system is a combustion chamber. So no reaction system is required, and it is a very fast test. And the setbacks is that it may require calibration with static tests. Caution are required in cohesive soil and in chalk, and is unsuitable for piles in excess of 40 meters depth. And it's suitable for testing pile groups and piles of variable or unknown pile shaft profile. So here is a video of the rapid load test. So this is how the test is carried out. So I'll be playing the video now. Yeah, this is the stagnatic load test or rapid load test. So this is more like the force from this system acts on the pile itself. So let me replay the video. So there's a reaction on the pile. Okay, and here's for the lateral load test, still the dynamic load test. So it exerts a pressure. So the force it applies is on the pile is taken by the engineers to determine the lateral load capacity of the pile. And this is a bidirectional load cell. It is a test method where a hydraulic jack or an assembly of hydraulic jack is placed inside the pile. Usually, it is usually placed at the end or at the end of the pile, towards the toe of the pile, and towards the end or towards the end, like this. So, and this is used to generate an upward and downward directed force movement. So when concrete is poured in here, so the hydraulic jack, the Osterberg cell, it tends to expand. It tends to expand, and this test is a destructive test. So it tends to expand, and the force is measured. The force and the settlements are measured with the dial gauges. Okay, moving on. So this is the Kentledge system. This is the Kentledge system where concrete blocks of known weights are placed on a frame. Say a frame is assembled over the pile to be tested, on which an amount of weights is safely stacked. And this generally takes the form of concrete blocks, or sometimes steel ingots can be used, as long as the weight can be assessed with reasonable accuracy. And the size of testing apparatus is generally a function of the pile size and the load that is to be applied on it. This is a reaction pile system. This is a reaction pile system with it transfers the forces. Transfer of forces is involved. Is carried out by a series of beams and bars and couplers. A number of reaction piles can be placed surrounding the test pile and will provide tensile capacity and act as reaction against compression test pile. So, okay, moving on. The allowable load from pile load tests. There are several standards. There's the ASTM D1143. That's the American standard, the British standard, BSEN, ISO 2247771, the Polish standard PNEN 12699, and also the Davison's criteria for determining the allowable load from a pile test. So now moving on to the Insitu Geo software. So I'll be sharing a screen of the software on the pile load test. So from here, okay. So this is the interface of the pile load test in the Insitu Geo software, and the Insitu Geo software analyzes vertical compression loading. So this input general, this session, that's the input general. It combines a recommendation from BS code as well as other codes and tests, so as to accommodate input from various standards. So this will accommodate for various standards. So here you input the project name, the test location, the type of method or the standard, the test number, the job reference, the weather condition. You input the date of test, the ground water level depth, the name of organization which carried out the test, the name of the address of the organization, the test operator was checked by, approved by, and here you select a vertical pile loading type, either the quick load, maintain load, constant strain, the incremental static, that's the cyclic load test for a single pile, and for the pile group, if you're testing on a pile group, the quick load test, the maintain load. So you select a vertical pile loading, and here you select the pile material, be it a concrete, steel, timber, or a composite material, concrete and steel, or concrete and timber. Okay, and here you input the pile elastic modulus. You input the pile elastic modulus. There are several. Okay, let me share a screen of some pile elastic modulus. Okay. So for pile elastic modulus for concrete, it's 15 to 40 GPA, for steels 200 to 210, for wood 11 to 16, based on the material you're using. So moving back to the Insitu Geo software. So I input the pile depth from ground level, the pile diameter, the pile shaft type, be it a uniform or on-rim or other, and you select a safe load criteria. We will come back to this, and you input the peak load applied during the test, the capacity of the loading jack, the number of settlement gauges, and also you input the total frictional resistance acting along the pile. Okay. Then input the settlement gauge calibration, the pile installation type, be it a board or driven or other, the pile section type, the input, then the description of the reaction load. For this demo test, I used Kentledge reaction system. Then if there are other general details, you input, and if there are unusual events, you input. So moving on to the inputs table. So because of time, I've already input data. So here, I input the dates. For this test, I input the dates and the time for each load applied. So I also input the jack gauge pressure and the individual time. Here, the individual time of loading, I input it, and here, after calibration of the jack pressure, you input the corresponding load value in kilonewton. So you input it, the applied load for the first cycle. This is for the first cycle. Then after that, the second cycle. So I also input the corresponding dial gauge readings. That's the settlement reading, the readings from the dial gauges. Since there are two dial gauges I use for this test. So I input this data. Okay, then checking the output table. Yeah, so I get the cumulative elapsed time in minutes, also the jack gauge pressure, the applied load based on my input. Then I get the total average settlement in millimeters at each loading. And I also get the settlement rate in millimeters per minute, a millimeter per minute. Then for the output graphs, the software gives me graphical representations, and each of the graphs in the software are required by different code, references, and text based on standard approach recommended in them to enable the software accommodate for various standards. Like we have the load settlement curve, we have the load settlement curve, settlement load curve, the logarithm curve, the time load curve. We have the time settlement curve, the load settlement curve. Also, for this time load curve, you can get the total amount of time. The total amount of time that was used to carry out the test. You can get in minutes, yes. And you can also get the time at which each load was sustained with this time load curve. And you also get how long the design load was sustained. So you can get how long it was sustained. All right, moving on to the results sheet, or before then, the output calculations and graphs. Now, based on my safe load criteria I selected in the input general, I'm not able to get the total settlement or the safe load. So I have to change the safe load criteria. So go to input general, then select a safe load criteria, say 50% of ultimate load. That's the final load at which total settlement is equals to 1/10 of pile diameter. Then let me move back to my, so here I get a safe load of 273.48 kilonewton. And I also get the elastic settlement of this, the elastic compression of pile for the safe load, the elastic settlement, the net plastic settlement, the total settlement, and the maximum settlement obtained during the test. You can also select other safe load criteria, say ultimate load over the factor of safety. Say my ultimate load is 300 kilonewton and a factor of safety of 2, just for example. So I also get output of that for that. So I have 150 kilonewton safe load, elastic settlement of this, the elastic compression of pile, the net elastic settlement, the net plastic settlement. I also get a total settlement for this load. So also for the pile group, you can select for the pile group. These criteria are for the single pile. For the pile group, you can also select the criteria. So that is for the output calculation and general details. Okay, now for the result sheet, you can check out the result sheet. Sorry. Yeah, so this is the result sheet. So I have all my inputs. The general details. I get the safe load, and the total settlement based on the criteria I chose. And I also get graphical representations based on different standards. So I get all this. So I can print my result sheet by pressing Control P on my system. So by pressing Control P, yeah. So you can print your result sheet, the number of pages you want to print. Say this is page 1, page 2, page 3. So you input the number of pages, say page 1 to whatever page you want to print to. And you can also save your work as a PDF by clicking here. Then Microsoft prints to PDF. So your work saves as a PDF. So you can print it out and attach it to your report, to your soil reports. Okay, we've come to the end of the presentation. I hope you've gained from it. And for questions and answers, you'll be required to rejoin using this same link. That's after 1 minute, you'll be required to rejoin for questions and answer. So I will see you in 1 minute's time. Thank you very much.